Our whole world runs on connected systems. I mean, everything from our hospitals to the AI factories that are literally building our future. But what happens when those connections get attacked? Today, we're going to look at one of the biggest cyber attacks in recent memory to really understand a huge vulnerability and then explore a potential solution that comes from a place you'd probably never expect. Okay, let's jump right in. And that's not hyperbole. Not at all. That's literally what the American Hospital Association called the 2024 cyber attack on a company named Change Healthcare. This one attack kicked off a crisis across the entire U.S. healthcare system, and it's just a terrifying example of how vulnerable we've become. 14 billion. Just let that number sink in. That's how many healthcare transactions Change Healthcare processes every single year. They're the pipeline, the critical plumbing for payments, prescriptions, insurance claims, the whole shebang. And when that plumbing got shut down by a ransomware group, the entire system started backing up fast. So let's break down what actually happened when this one critical piece of the system got hit. Because the consequences, well, they were immediate, they were widespread, and they were deeply, deeply human. The fallout was just catastrophic, and it went way beyond some simple data breach. You had patients who couldn't get life-saving prescriptions filled. Billions, with a B, in payments to hospitals and doctors just vanished into thin air, threatening their ability to even make payroll. Think about that. Rural hospitals, already running on fumes, were pushed right to the financial brink. And this, right here, is the key takeaway. Our super interconnected world gives us incredible efficiency, sure, but it also creates these massive, single points of failure. One successful hack on one company was all it took to trigger a nationwide crisis that affected millions of people who'd never even heard the name Change Healthcare before. Okay, so if an attack on a single healthcare company can cause that much damage, just imagine what happens when the target is even more fundamental to, well, everything. Let's scale up the problem and step into the world of artificial intelligence. Right now, the engine driving enterprise AI is pretty much built on platforms like NVIDIA's DGX system. They call it an AI factory, and for good reason. It's a powerhouse, an all-in-one solution for creating and deploying the next generation of AI. It's really the supercomputing backbone for the whole AI revolution. So who's using this AI factory? Well, it's basically a who's who of the entire global economy. We're talking the biggest names in telecom, in pharma, in auto manufacturing, plus top government agencies and universities. They are all building their AI futures on this one kind of platform. The concentration of critical infrastructure here is just staggering. And this brings us to the really scary question, doesn't it? If the Change Healthcare hack was the most significant attack on healthcare, what would an attack on the AI factory even look like? The potential consequences are almost impossible to wrap your head around, affecting nearly every major industry all at once. Defending a target that vast and that important is going to take more than just a better firewall, right? It might mean we need a fundamental shift in how we even think about connectivity itself. And that brings us to a new and really fascinating area of technology. It's called a quantum transceiver antenna, or QTA for short. Now, its developers are claiming this is a totally new kind of antenna. See, traditional antennas work one way, but the QTA is designed to use principles from quantum physics to create a connection that's fundamentally different and potentially way, way more powerful and secure. To get a sense of just how big a technological shift can be, just look at this comparison. Back in 2019, Intel was more than double the size of NVIDIA. But NVIDIA went all in on the AI revolution. 5 years later, the tables have completely turned. It's a powerful reminder that the right tech at the right moment can literally reshape an entire industry, practically overnight. So how in the world does this new approach to the antenna actually work? Let's break down the core concepts, at least as the team who invented it describes them. The easiest way to think about it is like a prism. You know how a prism takes in messy white light and spits out a perfectly clean, ordered rainbow? Well, the QTI is designed to do something kind of like that, but with radio signals. It acts as an ordering technology that can separate and focus a signal with incredible precision. And that, in theory, doesn't just lead to better efficiency, but maybe, just maybe, much higher security. So, what's the secret sauce? It's really built on 3 layers. First, there is new hardware designed to solve that pesky last-inch problem, getting a perfect signal right at the device. Then, and this is the crucial part, it uses a kind of digital lock and key to organize those signals. This isn't just about making the signal clearer, it's a security feature at the most basic physical level. And finally, a software layer manages the whole thing. And listen, the breakthroughs they're claiming here, they are pretty wild. The technology's white paper says it can penetrate solid objects like metal and rock, work without a direct line of sight, and even pull energy out of the air. On top of that, it can supposedly send and receive data at the exact same time and uses way, way less power. Now, these are some seriously bold claims, so let's look at the data they've presented. All right, so let's shift from the theory to the actual reported results, which, and this is important, the developers say come from independent third-party tests. The key word there is independent. The source material points to validation from labs around the world. So what did these labs actually find? Okay, this chart is where it gets really eye-opening. In a direct comparison, the QTA showed a gain of over 41 decibels against a standard Samsung antenna. Now, you have to understand decibels are a logarithmic scale. That sounds complicated, but it's pretty simple. A 3 dB gain means you've doubled your power. A 10 dB gain is 10 times the power. A gain of over 40 dB, we're talking more than 10,000 times the signal power. That's not just an improvement, it's a completely different league. And look, this wasn't just a fluke in one test. As you can see from this table from tests in South Korea, the technology consistently cranked out huge gains over standard antennas across a whole range of frequencies. This suggests it has broad, really versatile performance. So what do you do with that kind of performance? Well, you could finally bring reliable internet to rural areas, or provide the super robust connection needed for AI and self-driving cars. But let's bring it back to security. That lock-in key at the hardware level could be a game changer for securing financial and crypto transactions. For first responders, it could mean creating a secure omnigrid that works even when all other networks are down. When you boil it all down, the ambition here is to build a completely new foundation for connectivity. The goal is to finally solve that persistent last inch of the last mile problem, to ensure a signal that isn't just reliable but is fundamentally more secure, right from the ground up, right at the device itself. And this quote from the company's CTO really just brings it all home. The argument they're making is that the challenges we're facing now, especially when it comes to securing massive, complex systems like the AI factory, simply can't be solved with the old physics. They believe a new approach, based on quantum principles, is the only real way forward. Which leaves us with this one kind of fascinating final question. We started with a single cyber attack that brought a nation's healthcare system to its knees and saw an even bigger risk to our AI infrastructure. Is it possible that the defense against these massive, complex digital threats isn't some new kind of software, but in completely rethinking the most fundamental component of all our technology, the antenna? It's a powerful thought. Thanks for watching.